Hello, Algebra 2 students. This is Mr. Fox. Today, I got a great question via email from Colby Johnson. Colby noticed that during our example for our work today, we actually saw how to solve a trinomial that had a leading coefficient that was greater than 1. Colby's question is that on our homework, it seems that we only have trinomials that have a leading coefficient of 1. So, how do we go about solving these? Well, this is a great question, and the answer is that we're going to do the exact same steps, right? So let's go ahead and list those out. So we start by saying step 1. And step 1 is to put it in standard form. And remove the GCF, which stands for greatest common factor. Now, fortunately, in each of these terms, the greatest common factor is actually just 1. So, we've already completed removing the GCF, and additionally, I already have this in standard form. So step 1 is complete, so I can just rewrite x squared plus 8x plus 12. All right, then we move on to step 2. And step 2 is to multiply the first and last term. So when I multiply the first and last term, I'm talking about the coefficient here and the constant here. So I multiply those two numbers together. So I multiply 1 times 12, and I get 12. All right, then step 3 is going to be to factor the product that we got from step 2 and make factors that add to give me the middle term. And my middle term is this one right here. So we're interested in making numbers that will add to make 8. So let's go ahead and factor 12 here. So if I take 12 and I factor it, it's going to become 6 and 2, and then 2 and 3. Okay, so I need two numbers which will multiply to make 12 and add to make 8. So I notice that any of these numbers, right, these numbers down here, they will all multiply, no matter what, to make 12. So I can rearrange these in some way so that the products will actually, the factors themselves, in addition to multiplying to give me 12, they will add to make me 8. So let's see how this would work. Well, for instance, if I just wanted to take each of these products individually and see if they'll work, then I would say 2 times 3 times 2. And that gives me 12. But when I try and add those, I get 2 plus 3 plus 2, and that gives me 7. So that wouldn't work. So just using the products, or using the factors at their base will not work. What I notice, though, is up here I have 6 times 2. And we see that 6 multiplied by 2 gives me 12, and also 6 plus 2 is equal to 8. Therefore, my two factors are going to be 6 and 2. Our next step is that we're going to break our trinomial. So now that we know the factors which will add to 8 and multiply to make 12, we can take our trinomial and what I want to do is I actually want to break it down such that our 8x becomes the two pieces which will add to make it. So they'll become 2x plus 6x. Then we'll just pull down our other pieces directly, and I'll get x squared plus 2x plus 6x plus 12. And our final step, step 5, is that we're going to factor by grouping. So we take our expression, x squared plus 2x plus 6x plus 12, and again, grouping is when we're going to break it into two pieces and try and use that distributive property to give me two factors. So we've got this piece over here, and we have x, and here we have 2 and x, and we see that they share a single x. So we have x, and then in here we have x plus 2, because I'm going to pull down this plus exactly where it needs to be. All right, then over here we can do the same thing. So we start with saying 6 and x, and for the 12 we have 6 and 2, and we see that they share this 6. Therefore, we have 6, and then what's left over? Well, we have our plus, our parentheses, x plus 2. Therefore, my answer, after I use the distributive property, will be x plus 6 multiplied by x plus 2. I hope this video has been helpful, and have a wonderful day.